Welcome, everybody. Thank you for joining us today. Today we have Daniel Bursch, a NASA astronaut, joining us here at Google to tell us about his fascinating stay at the International Space Station. I'm really interested about what he has to tell us about this because one of my interests is Mars exploration and possible human missions to Mars. And one of the elements of those missions will for certainly be a 6-month trip to Mars. So Daniel Bursch had 3 space shuttle flights and this stay in the International Space Station. He has a long and distinguished career at NASA. And I'm not going to read, like this long resume that you may have sent at the Tech Talk announcement. So please give a hand to Daniel Bursch and welcome.
Thank you, Boris. Thank you. Thank you very much. I'll first start with a disclaimer. The bad news is I had to take vacation to come up here, but the good news is I got to use the Google dress code, not my normal dress code. And also, I'll try to be as frank as possible as I can during the talk, because one of the biggest challenges, I think, of long-duration spaceflight are the psychological challenges. To kind of set a seed right now is think about, for the next 6 months, never getting out of your cubicle or out of a Winnebago if you went out for a long trip. So, and with 2 other people in the same can with 2 other people. So that just sets the stage for some of the challenges that we had up there. Most of my talk today will focus on the 6.5 month. The half becomes important, especially to my spouse, who reminds me that it wasn't just 6 months, it was 6.5 months I was away from home. But on my last mission to space, which took place from December 2001 to June of 2002. This is a mission patch that describes that at the top there. If any of you, Gavrite Paruski, it's Russian. It's in Cyrillic letters for Yuri Onofrienko. He was our commander for Expedition 4. And then my name on the right and Carl Waltz on the left. One of the things I had to do was learn Russian. When I started training in 1997, didn't launch till 2001. But guess what? The Russians have their own acronyms. ISS on the left there, International Space Station, and it's not MKC, it's actually MKS on the right for Международная космическая станция. So as part of the deal, Yuri learned English as well as he could, and Carl and I learned Russian as well as we could, but overall it went very well. And again, I'm here representing Dan Bursch, myself. I currently work for the Aerospace Corporation, and they support a chair position at the Naval Postgraduate School, which leads me into to the next slide. Some of you may know that Captain Michael Smith and Commander Willie McCool, they were both pilots on space shuttles. Mike Smith was a pilot on Space Shuttle Challenger, and Willie McCool on Space Shuttle Columbia. Most people don't know it, that the Naval Postgraduate School, that's not too far away, 70, 80 miles away from here, has graduated more astronauts. Basically, more astronauts have become graduates from the Naval Postgraduate School, have become astronauts than any other graduate school in the world. And 2 of those perished in the space shuttle accidents. What I'm trying to do is to collect funds for an award, a student award in honor of Captain Mike Smith and Willie McCool. And I have the information here. I'll repeat it later. But if you choose to contribute, the information is there. It might be easiest just to call the number, the 831-656-2339. But I've always thought it's important. Throughout my career, I've been very fortunate, had maybe a few close calls, either in the Navy or with NASA. But there's a lot of people who haven't made it, and I thought it was important to remember both Mike Smith and Willie McCool. So with that, here was our crew of 3 on the International Space Station. I say we were lucky because we had a crew of 3. As you recall, after Columbia, we couldn't get enough astronauts up and back, or actually enough food and water and clothing to International Space Station after the Columbia accident, so they went down to a crew of 2 for a period of time. But I say we were lucky because as a parent, I remember always hearing, never let your kids play in threes. And so we were a crew of 3 on space station. I started scratching my head. So, but and I'll talk a little bit about that, how that comes into play. My recommendation for any mission to Mars: make the crew as large as possible. Okay, and this is unusual to have a crew of only males. We happen to be all military. On the left, at the time I was active duty Navy. I was a naval flight officer, as they affectionately call and used to call in some of the fighter airplanes. I was a GIB, a guy in the back. But I was actually a GOR, a guy on the right, because I flew in an aircraft called the A6 Intruder. Then Carl Walz on the right, he was a flight test engineer for the Air Force, and Yuri Onofrienko, Air Force pilot. Yuri had flown once before, but was on Mir space station, so he already had a 6-month deployment under his belt. Launching in the space shuttle, fully fueled, weighs about 4.5 million pounds, produces about 7 million pounds of thrust, allows us to accelerate, of course. My wife gives me a hard time because when people say, well, Dan, what's it feel like when you launch in the space shuttle? And I always say, well, my experience of launching off the aircraft carrier, it just felt like a catapult launch off the aircraft carrier. It just lasted a lot longer. And my wife goes, yeah, Dan, most people know what that feels like. But that's what it felt like to me. It felt like launching off the aircraft carrier, and instead of going 0 to 150 miles an hour or so in 2.5 seconds, we went from 0 to 17,500 miles an hour in 8.5 minutes. It just keeps going, going and going. And we accelerate fairly rapidly. This was the first time I sat in the mid-deck, so lower portion in the shuttle, so I had no outside viewing, no window close by. And so it actually allowed me to feel, if you remember the space shuttle, when it launches, it actually rolls rather quickly. Once it clears the launch tower, it rolls rather quickly. And I remember in my previous launches, I was so focused on the instruments, I almost never saw that roll or felt the roll. But just sitting in the mid-deck where all I had was to feel the acceleration, I could actually then feel the roll when we went off the launch pad. Those boosters last for 2 minutes, and then they fall off. It sounds like a big thud when they come off. And the acceleration actually decreases to less than 1 G. So you start on the launch pad on your back, feeling 1 G. You accelerate to up to 2.5 Gs, and then at 2 minutes, it goes back down to less than a G. It gets very smooth. First stage is very rough. There's a lot of vibration. There's so much vibration that it's really hard to even read the instruments in front of you if you're on the flight deck. So that's why we really rely on the ground to help us out with any problems there. And then once you lose the solid rocket boosters, it's almost like an electric drive. It's very, very smooth. This was our holiday photo in space. We decided to go with the Russian wear for this photo. They have about half of our food was Russian, half of our, I wouldn't say quite half of our clothing was Russian, but part of the many international agreements I had to go on before we flew in space. And this happened to be in the Russian segment, and a lot of the psychologists, the Russian psychologists, had more experience with long-duration flight with the Russian Mir program. And they told us that some of the challenges, they told us to watch out. Actually, this was part of our training. They said around the 3-month or 4-month time frame, look out for signs of depression in your crewmates. And this is like several months before I'm flying, and I'm going, what am I getting into here, okay? So, but it was good. I mean, but actually for me, the toughest part of the flight was just at the beginning, because around the holidays, away from my family, and incidentally, when I went off before I left Houston to go to Florida, I remember trying to sneak out of the house at like 6 in the morning because I knew my 5-year-old then was having a really tough time with me leaving, and he kind of caught on that Dad was going to be leaving for a while, so I tried to sneak out of the house at 6 in the morning, but sure enough, he wakes up, and so I'm trying to sneak out of the house at 6 in the morning with my 5-year-old tugging on my leg, begging me not to leave. So as a parent, that was hard. That was hard doing that. So this was our Christmas photo, a tough time, but there were a lot of, at that time in in late 2001, there were a lot of people that were deployed in service of our country. So it was real easy for me to say, okay, I'm okay. At least nobody's shooting at us, or there might be stuff out there that I don't know about, but at least nobody's shooting at us in space station. When we orbit in space shuttle or space station, I say we're only about 200 nautical miles or so above the surface of the planet. And if you know that, I believe that the diameter of the Earth is on the order of about 7,000 nautical miles. So if you think about it, if you're only 200 nautical miles above the surface, we really are kind of skimming over the surface. This is kind of what a view looks like if using probably about, I don't know, 400 millimeter lens, maybe a little bit less to zoom in on the ground. But this is the Kennedy Space Center in Florida. And you can see the two launch pads there in the middle of the picture, 39A and B, that originally launched the Saturn rockets. And then in the lower left here, you can see the shuttle landing facility where the shuttle likes to land, because then most of the time it saves some money in processing. I'd been in orbit about 2 months, and Yuri was a good commander. He pretty much let us do our thing, as far as I'm sure everybody, no matter where you work, there's certain types of bosses you like or dislike, but Yuri was good. He let us be in charge of our experiments, our projects, let us do them, and then on occasion, if he felt he needed to get an update, he would ask for it. One time, I think he felt like I had just been working inside too often, and so he grabbed me and he pulled me towards a different window. Most of our windows on space station look towards the Earth. They're nadir, or they look towards the Earth. So to get a view of a sunset or sunrise, and we see this view every 45 minutes. We go around the Earth every 90 minutes, see this view about every 45 minutes, and quite honestly, I don't even know if this is a sunset or a sunrise. They look so, you see so many of them, if you're watching for it. So he pulled me towards a window that happened to look towards the horizon, and it was just one of those moments, he felt like, his crew member needed a little bit of time off and just look at the sunset. So after about 15 seconds, he said, good, okay, now go back to work. So this was an experiment in testosterone levels to see if they stay the same in orbit. No, actually, no, it wasn't. Actually, this was after our first spacewalk. I had done probably 9 years of training in a US suit to do a spacewalk. My first spacewalk happened to be in a Russian suit. And this isn't just stylish Russian evening wear. This is actually, this is an undergarment that we wear inside the suit. In the next picture, you'll see what the spacesuit looks like. But in space, as you know, we don't have any free convection. Hot air doesn't rise in space. So you do have forced convection, where you force a fluid or air around, and then you can get some cooling. And then we have conduction. So what's difficult to see here, but there's thousands of feet of plastic tubing throughout that suit, and that's what cools us inside the suit, because believe it or not, even though temperatures get very cold and very hot in space, inside the suit, it's your own heat that you have to get rid of as you're working in the suit. So that's taken away by those tubes that go around that stylish underwear there. I used to say I need to take this slide out of this presentation, but I came up with something different today. So this is a Russian suit. The Russian suit works at a little bit higher pressure. I know there's probably some scuba divers in the audience, but for when we go on a spacewalk, we have the risk of decompression sickness when we go on a spacewalk, because we go from about 14 pounds per square inch, a sea level atmosphere inside space station, to where in this suit it works just over 5 pounds per square inch, and the US suit works even lower at 4 pounds per square inch. So the advantage of working in a higher pressure suit is that you can get out the hatch a little bit earlier. You don't have to pre-breathe as long. You don't have to scrub the nitrogen. It doesn't take as long to scrub the nitrogen out of your bloodstream when you go. The challenge, though, working in a higher pressure suit is then you're working against the pressure with your gloves. It's also not, you're not going to go out and fix the Hubble Space Telescope with this spacesuit. However, if you need to get out, fix something, a rough operation in a hurry, you can do it in this suit. The other thing about this suit is kind of one size fits all. I don't do real well in a one size fits all anything. And I actually had probably about that much room between the back of the suit and my back, so it was difficult to work in this suit. However, just like anything else, you learn to work with it, and you spent many hours training to work in it. This is inside the Soyuz capsule. The Soyuz capsule, I went up, Space Shuttle Endeavour took us up in December, dropped us off, and then they left after 7 days, and then the three of us were left on board space station. The Soyuz capsule becomes our lifeboat when we're up there. So if something were to happen where we couldn't save space station, we had to get to the ground, or we had some medical emergency, we could get back quickly with the Soyuz. That also brings up the issue of going on to Mars. If you have a medical emergency on the way to Mars, there could be a point where you're not going to get back for several months. It's just the orbital mechanics. It's going to be a long time. So that's another big thing to think about, too. If people have a serious enough problem to where they may not make it for the mission, then you have some choices to make on that. So that'll be a challenge as well. But the Soyuz, there's not a whole lot of room inside of that. But with my size, I felt pretty comfortable inside there. You probably recognize this picture. You see the Bay Area. This was taken probably about the March, April time frame of 2002. And this is a little bit, this is probably taken with a 50 millimeter lens. So this is probably if you took your 50 millimeter SLR camera and took a picture. And then if I get my geography right, I guess 101 probably comes up this way, and we're probably Google maybe around this area. I know it just passed. So I'm pretty sure this is Moffett or Ames here, so just close to here. This is taken at the same time, still with a color. Basically, it was a digital camera, but it's supposed to be a color picture. Tough to tell that just with the sun blooming out. But some of the things that you can see with the picture are some of the waves coming off the pylons. If you can see the Bay Bridge in the lower center of the picture, you see Treasure Island, and Alcatraz is north of that. You see the Bay Bridge up at the top, but just the things when you get the sun angle at the right angle, the things that you can see just when you look down at the ocean. Here's Monterey Bay. Naval Postgraduate School is located right about here. When I first got that picture back, if some of you know the geography, know that at the right there is a Salinas Valley. And when I first looked at this picture, I was still in Houston, and I thought, well, this must be early morning or late afternoon with maybe some fog settling in. And after living there several years, now I know that can be any time of the day that fog rolls in that area. It's nice to come up with get an increase of 20 degrees or so to come up here. This is on the East Coast. And right now, you're probably thinking, what'd this guy do through his whole mission? Did he just take pictures the whole time? Well, what I found enough experience of giving these talks is that people really are interested in mostly as far as visual to see what it looks like from Earth. Most of the time, everybody would set little timers. If the ground would say, we really want you to get a picture of Patagonia because the weather's clear at the time, so everybody would set their little timers. And so you'd hear this timer go off, and the first question would be, whose timer is that? And then you'd try to find a window and then get your camera ready and take the picture. But this happens to be on the East Coast. The picture's kind of rotated, so north is on the right side of the picture. Any guesses of where this might be? Yeah, you'd have to be from the Norfolk area, but this is actually entrance to the Chesapeake Bay. If any of you have been over the Bay Bridge Tunnel, it's a combination of, I think it's about 22 miles long, combination of a bridge and tunnels over the mouth of the Chesapeake Bay there. You see the Delmarva Peninsula to the lower right-hand part of the picture. And other things that you can see just from the photo, again, you can even see ship wakes from that altitude. Space station, when it's on orbit, actually loses about 200 meters every day in altitude, so it does have to make it up, and most of the drag comes from the solar panels, because even though it is technically a vacuum up there, there are still molecules that eventually slow down or bring the spacecraft lower. So every so often they do have to boost up the orbit because it continually decays just because of all the drag, and it's only going to get worse because of the increase the number of solar arrays on board. Storage on space station is a lot like storage here in California. There's not a whole lot of it, unless you want to pay for it. So here's the airlock on board. This is the U.S. Airlock on board space station. When it's not being used, it becomes a closet. But then if you want to use it as an airlock, what do you have to do? You have to move all your stuff out. So that's what we did a few times. A lot of people say, well, why'd you have two kinds of suits on space station? Why do you have a Russian suit and a Russian airlock and a US suit and a US airlock? Actually, one of the things I've found is through international cooperation, a lot of times you get built-in redundancy. Because if you have people that are trying to achieve the same mission, let's say to go on a spacewalk, they have similar equipment, but they've been designed differently. So if you have some generic fault with some of the equipment, you can use the other companies or other countries' equipment to achieve your goal. So I think the one good things about international cooperation is not only just the obvious benefits of working with other people throughout the world, but also you get some built-in redundancy with your equipment. So this was after we cleared everything out. My second spacewalk was actually in the US suit. US suit, a bit more expensive than the Russian suit. It is more custom fit. However, it also gives you a bit more dexterity, works at a lower pressure. But there's trade-offs with everything. It takes us a little bit longer, maybe a couple more hours to get out the hatch. So if you needed to get out in a hurry, you might choose one suit over the other. But it did, the two suits did give us some built-in redundancy. And actually, after Columbia, I don't know if you knew it, but most of the spacewalks were done in Russian suits because they were just designed to be on orbit a longer time, albeit you couldn't do the type of tasks that you would want to do, if you needed the dexterity to do it. Different philosophies in using the suits, too. Part of the training process is that if I wanted to use the Russian suit, the Orlan, it was the Russian trainers and the Russian doctors that had to certify me to use the suit. So that was, again, part of the international agreement, so that, and there were different protocols, because a protocol meaning if you go out in the US suit, we had a constant tether. It was like a tether reel with a wire that was always attached to you. The Russians don't do it that way. They have two tethers with hooks that you would manually change as you go along, and always using your hands to hold on. And that took some use to. You almost had to make a mindset when you're training in one suit versus the other. In some cases, you could just let go with the US suit. Not advisable, but you could, trusting that wire tether. And I remember coming back in the Russian suit one time. It was after that Russian spacewalk. I was about 5 feet from the hatch, so I wasn't very far from going back into the hatch. But I had moved my tether, one of my tethers, and I reached back to grab my other tether, and it was floating free. So at that point, I think on the ground they saw my heart rate go up a little bit. Anyways, but that was a close call. Unfortunately, nothing happened with that. This is inside the U.S. laboratory on space station. They have terms. They say the U.S. segment or the Russian segment. At the end of this year, they're supposed to launch the ESA, the Columbus module, up to International Space Station. That'll be a big step forward for the international partners. But inside space station, it's fairly roomy. The amount of, I speak in terms of square footage because that's probably what people can relate to as far as sizes. But I would say the equivalent was about equivalent of maybe a 1,200 square foot home. But it's kind of, if you can think of it, it's all kind of in hallways, kind of the configuration. Now, it felt bigger than that because, of course, we're floating free and we can use, the 8 or 9 feet above us, freely and float around. And sometimes you could actually even float upside down, close your eyes, and then open your eyes and make your brain think that the floor is now the ceiling and the ceiling is the floor. And sometimes just for, the things we do for fun on space station, one of the things I did for fun on space station is normally you're a creature of habit. I'm sure everybody when they come to work probably has a stairwell, a way that they get to work, the shortest distance maybe, or it goes by one at your favorite cafeteria. Well, on space station, we seem to always translate down, along the floor because for whatever reason that felt more comfortable. And then about halfway through the mission, I said, well, I'm going to start translating on the ceiling and see what that feels like. And it was really strange because all of a sudden I was like, wow, I didn't know that was there. I mean, you'd think that living in this small area, you'd figure that out, but just the tricks that your mind plays on you. So if you can think about it, again, 3 people in the same, I say can, now it's a very complicated can and complex, and it was very comfortable and everything. But again, it's working with 2 other people in very close quarters for a long time. This was a robotic workstation. The Canadians built the robot arm that's on space station. They also built the robot arm that's on the space shuttle. And in fact, if Columbia had the robot arm installed, one of the reasons why Columbia couldn't inspect it with a robot arm is that they took it off for weight savings. They saved several hundred pounds by taking off the robot arm. One of the mistakes now, they always fly the robot arm because you can use it to inspect other areas around the space shuttle. One of the differences on operating the robot arm on space station, though, was that we didn't have any direct viewing. On the space shuttle, you kind of have the back window to look out over the cargo bay or payload bay, and you can fly the arm many times just looking at it directly. Whereas here we had to use only cameras, and you don't get that 3-dimensional type feeling when you're flying it. So that was one of the challenges of learning how to fly that robot arm. This is an abandoned copper mine in Ajo, Arizona. I still believe it's abandoned, but one of the reason I put this slide in here is you see the shadowing effects on the ground. A lot of times you'd look at the ground and you'd try to pick out, let's say, a valley or a mountain, and sometimes you look down and you're not quite sure, okay, where's the valley, where's the mountain, if you're trying to get a picture of something, and just some of the effects that shadowing does when you're trying to see some of these features. Here's anybody recognize that? Yeah, San Diego, Coronado. Most of the time, the cities tend to have that grayish look to it. And in fact, whole continents tend to have kind of a color, their own color. So if you're up there long enough and you see it, you could look out the window, and without even looking at, let's say, a world map that we had on a computer, you could actually, on a laptop, you could actually just look out and see the color and go, okay, that must be Australia. And a close-up of Coronado. Now, this is a little bit fuzzy, and I'm going to blame it on going the 5 miles a second. The 17,500 miles an hour is equivalent to about 5 miles a second. So when you're trying to take a picture, I think this was like with an 800-millimeter lens. It wasn't the camera. It wasn't the the photographer's fault, of course. It must have been just that 5 miles a second, where you actually have to kind of move the camera, rotate it a little bit as you're taking that picture. This is in the southwest part of South America, an area called Patagonia. I talked briefly about it before, but it was at a time, usually this area is just covered with clouds and they can't take pictures of the area, but there are several glaciers in this area, and they told us, the ground asked us, hey, when you pass over that, can you take as many pictures as you can, just to try to document the size of the glaciers. And latest I've heard is that the glaciers are receding at somewhat of an alarming rate. One of the interesting things that I really didn't notice at the time, but after you look at the picture, you look at the lower right and you go, well, that glacier looks like it's breaking up a lot differently than the glacier up at the top of the middle top of the photo. And the only thing I can surmise is that that's enclosed water right there is probably cooler, colder water, and the glacier isn't breaking off as quickly as the one in the lower right, which probably has some entry into the ocean. Access to the ocean. And I call this glacier art, just eventually taking these pictures. And again, we didn't spend all of our time in the window, and actually it was probably less than 1% of our time working up there. It was a combination of either things broke, you had experiments to work on. If you're getting ready for robotics, you had to do some things to prepare for that. If you're getting ready for a spacewalk, you had to prepare for that. A lot of times, we ended up doing a spacewalk that really wasn't planned during our mission, and they actually sent up the procedures, and we were able to use basically a virtual reality type of a 3D picture on a laptop to help train us for that spacewalk. Here's in, I believe this is in Guatemala. They want us to take a picture of a volcano that seemed to show some activity. It was cloud covered at the time, but a lot of times you look out the window and you see contrast and you say, well, that looks interesting. So you go ahead and you take a picture of that. And at the center of the picture apparently was a volcano that had already erupted probably the year before. And then what you see, the remnants of after many rains, all the ash flows down and chokes the rivers that come down from that volcano. It looked like it was having some smoke up there, some burning. one of the challenges while I was up there was, before I went on this, and I'll call it a deployment, I'd been in the Navy and gone on several deployments on aircraft carriers and larger ships, and I felt, well, the deployment's going to be no different than being on a ship in the Navy. Well, it was much different because it's almost like going to deployment in the Navy and never getting out of your stateroom. I mean, you're with the same people. You couldn't go to flight deck, go for a run. Exercise was important. It was a time where you could have kind of by yourself and not only feel physically good, but mentally it was a time kind of to recharge your batteries. And just the aspect of just knowing that you weren't that far from home. 200 miles isn't that far, but to get home is a pretty big event to do that. So that was one of the biggest differences of a deployment, let's say, for me in the Navy versus deploying on the International Space Station. This happens to be Key West of Florida. The Navy, for some reason, seems to get some pretty good places throughout the world. I guess they always have to be near water. So one of the challenges, one of the things that I found was that not only before you fly in space, I mean, you have your list. What was it? OKR? Did you say for OKRs? Everybody has their OKRs. You have your goals. You want to achieve these things. At Google, I had my own list of goals. Of course, I wanted to. Bottom line, my wife said you have to come home safely, or don't bother coming home. Trying to figure that one out. But and so one of the my own kind of goal that I came up with is I wanted to take a picture of certain spots around the world. And so this happens to be the Naval Academy. If you look in the top center of the picture there, Naval Academy, a lot of the playing fields are built on the landfill that goes out in the Severn River and out into the Chesapeake Bay. So one of my goals, I said, I want to try to take a picture of every place I'd been in the Navy. And that was just like one of these personal goals had really, it was hard to describe other than it was something that I knew I had control over, because every minute of every day on orbit, the ground pretty much controlled our schedule. We would check the laptop computer. It had the schedule. This is what we're supposed to be doing. We had a little bit of leeway, but for the most part, everything else was controlled. So the ability on a long mission to just come up with something only you wanted to do. You didn't have to tell anybody. You didn't have to get it approved. You didn't have to have peer review, look at it, and do all these things. You just did it, and that was important for me psychologically. Just being in an environment that's kind of isolated, but with other people, but somewhat of an isolated environment. Here's Patuxent River, Maryland. That's where the Navy Test Pilot School is. I went through not as a pilot, but as a test flight officer, as a navigator at that school. That was actually where I first got interested in the astronaut program, because I guess everybody likes to do field trips, and as part of the school, we did a trip to the Johnson Space Center, talked to some astronauts. There's all different kinds of astronauts. We have astronauts who've never been in the military. Most of the pilots have been in the military. We have mission specialists that some have been in the military. Most have not been in the military. But that was where I ended up finding out about I could become a mission specialist with my background. And actually, the requirement to be a mission specialist is you have to have a bachelor's degree, preferably in the sciences, and then you apply to NASA, and they like to have 3 years experience plus a bachelor's degree. A PhD can be in lieu of the 3 years experience, so that's why a lot of times you see the mission specialists with PhD that become mission specialists, or astronauts that are mission specialists. So the bottom line requirement is to have bachelor's degree, and so we have a lot of different. I keep talking the present. I'm a former astronaut, left the office a couple years ago, but it's kind of hard to let go after so many years and experiences such as this. Here is Naval Air Station Oceana in Virginia Beach. Being on deployment, kind of even when you go on, I went on a cruise ship for the first time many years ago, and a real cruise ship, not on a Navy cruise ship. And even on the beginning of the cruise ship, what do they always do? They have a drill, right? They kind of have a drill, get everybody together and discuss that. This is what we were doing here. Does anybody guess what specific drill we're doing? CPR. We were doing, so this week was our CPR, our medical emergency drill. So we brought out all of the medical equipment that we had. If you look down here, it's basically a resin non-conducting surface, because we did have a defibrillator on board. And if you put somebody down and didn't insulate them from the rest of the space station, you'd give the whole entire space station a good shock if you use a defibrillator. Yuri was busy at the time, so what we used was, and if you look closely, it's good old duct tape. Duct tape works great in space as well. So we took some towels, rolled it up, tried to get about the right distance for Yuri's chest. What I was trying to show was that to do the chest compressions, it's actually easier to push off the ceiling, well, what you could consider the floor, depending on where you are, and to do it that way, other than, because the first guess when you get up into orbit is to do everything just like you do here on Earth. But what you find out is that when you're weightless, it's a lot easier to do it a different way. So that's what we were doing here, and practicing the two-person CPR with Carl at the head of the patient. I'd been in orbit about 2 months, and I went to Yuri, and I said, Yuri, I really, not only was the places I'd been, it was some of the places that just fascinated me. I'd read the book, Into Thin Air. Has anybody read that book before? I'd read that book. I really wanted to get a picture of Mount Everest. So after 2 months, I went to Yuri, and I said, Yuri, I've been trying to get a picture of Mount Everest, and I can't get it. And Yuri just goes, don't worry, it will come around again. And so sure enough, he was right. You wait long enough, you stay in out of orbit, and you'll find it. It happened to be about 3 in the morning, basically our sleep time. Incidentally, we would run by GMT time. We'd wake up about 6 in the morning, go to bed about 10, 11 at night GMT time. So it happened to be 3 a.m. GMT time. In the middle of my sleep, I got up, happened to see that we were going to be flying over the Himalayas, so I got my camera ready. I knew to look for, if you look at the top, near the top center of the picture, there's a big upside down V, and I knew that kind of pointed north. And if you look down the east side, that was where Mount Everest is, and so Mount Everest is right up there. And but again, you see when you're up there, it's really hard. You might look at this area and go, well, that area might be higher, or that area might be higher, and so I got my picture of Mount Everest. And again, I don't know how to describe this other than like one of those little personal goals, like, yes, I did it. I was able to do that, and it wasn't on a timeline anywhere except my own. We wanted to promote reading, so yes, this still has a canned photo used with a timer on the flash. What I didn't realize was after the photo, you notice Yuri's hair getting a little bit longer. I'll talk about that later. But Carl, I think, wins the award for, I guess, the intelligence quotient for what he's reading. He's reading Stephen Ambrose and Wild Blue. Yuri's reading an atlas of fishing in the Moscow region. Yuri was what they call a nastoyashi rybak, which means a real fisherman. We would fly over Newfoundland, and Yuri would just look out the window and just be salivating, because he just knew all the fish, the plethora of fish that would be down there, but he was so close yet so far. And then yours truly, I have Harry Potter, okay? So what can I say? Every so often, about it seemed like in the middle of the mission, we had a Progress is an unmanned Russian cargo vehicle that comes up, docks, and it's kind of like a supply ship for space station. So along with material supplies, it would also deliver small amount of fresh food. And I remember when it first came up, before we opened the hatch, and this was the first visit by anything. We had been on board 3 to 4 months, and we hadn't had a visit by any other ship. And so this is the first time our families are able to put in a small package about yay big, little letters and cards and stuff like that. And of course, we could communicate them with an IP phone every day that we had, but we didn't have a constant internet connection. It's kind of like my like my connection at home. I won't mention the company, but it's sometimes it's there, sometimes it isn't for the broadband. But that was kind of on orbit. But so we had good connection with home, but there is something special about getting a package, So before Progress came up, I was really excited. I was like a kid before Christmas, I wanted to open up that hatch and see what I got. And when I opened up the hatch, I smelled the fresh oranges and apples, and it just overcame me because we don't have fresh food up there. We don't have well, we have some medical refrigerators or freezers, and sometimes people like to sneak, you know, little ice cream bars and stuff in there that they're not supposed to. But anyways, I remember opening the hatch and smelling the fresh oranges and apples, and it just overcame me. I don't want to get into specifics of what inside of space station smells like after 3 months with just 3 guys on board, but to smell the fresh oranges and apples just was something that, you know, you take for granted, just the senses that you don't think about when you're in this enclosed environment for a long time. This is Aurora Australis, so the southern lights, and this picture doesn't do it justice. One of the things that hopefully will improve with technology is just the sensitivity of the cameras, especially in color, when we take some of these pictures, how you can bring back some of these images. And of course, they somewhat dance around the auroras, and they're beautiful in space. On one of my previous missions, we were actually only at an altitude of 100 nautical miles. I remember actually flying through the aurora, and that was kind of eerie to see it kind of dancing around the space shuttle as you flew through it. Here was a Space Shuttle Endeavour coming up to pick us up. And this was kind of an exciting moment because I knew the mission was coming to an end, but at the same time, I'm thinking of the crew inside the space shuttle that's just beginning their mission. So kind of different types of thoughts that go through your mind when you see your ride come up. Now, of course, you're really happy when they dock and, you know, everything's okay and they come on board. But in the cargo bay of the shuttle there, you see one of the pressurized logistics modules that basically is a huge suitcase, which later is pulled out by one of the robot arms and attached to a space station. So there was our the crew that we traded off to is in the light blue shirts, and included Peggy Whitson on the right. You know, there was a lot of, I remember in the office, a lot of concern, oh, this is Peggy Whitson, it's her first mission, it shouldn't be a space station mission, and because of long duration, but she did great on her first flight, she did great. You see Yuri in the middle. By the end of the flight, we nicknamed him Fabio. Both Carl and I got haircuts, and the way you do haircuts is you get in front of an intake for the air vent, and the filter collects all your hair there, and then you actually vacuum it up. So it's not real high tech, but you want to do that because this stuff just will float all around if you don't do something about it. And I asked Yuri, I said, well, Yuri, why don't you want to get your hair cut? And he explained that he had been in the military so long, this is the only good excuse he had for not to get his hair cut. But for me, it was just convenience thing, you know, because of the resources we have there. We have a waterless shampoo, but I mean, it works okay. But believe me, when I came back down to Earth, getting a nice, real shower was really good. It felt really good. So it's just almost like a timing thing, convenience thing for me. It's just interesting. I told Yuri I don't believe the haircut bit about being in the military. I thought he just didn't trust the Americans with sharp objects. So. Leaving space station was somewhat of kind of an emotional event because I remember, of course, when you're approaching space station in your space shuttle, there's like maybe mainly 2 windows that you can look at as you're approaching, and that's pretty prime real estate for 7 or 8 people to start, you know, shoving for space. And of course, the commander gets whatever he or she wants, and then, you know, everybody else gets whatever they can. But so you try to get a picture, but all I can say was just a cycle. After going through this mission and then leaving it, it was almost like my brain had been recaged as far as just a different viewpoint. And so as I was leaving space station, it was kind of an emotional moment because I look back and I go, gosh, I spent over 6 months on board, and that was my home. So you're leaving your home for a long period of time, and chances are I won't go back, or at least my wife says I won't go back with that wife. So, but anyway, so I just remember leaving it and just being kind of it just surprised me. One of those things psychologically that surprised me. I figured I should be happy I'm going home, but just leaving something that was your home. And it truly is I still think an engineering marvel, especially in the number of countries that are involved with it. You see the large solar arrays. Also, you've probably seen this, people show it before, but look at the Earth's atmosphere. You see that thin blue line. over the horizon of the Earth. It's very, very thin. It really gives you an appreciation of how very, I mean, the atmosphere seems like a thin shell around the planet. Here's a close-up of a space station. That's kind of basically how it looked like when we left it. If you've seen pictures, you know that they've built on several segments to both to the left and right side of space station there, and added on some more solar arrays. This is actually the docking port where the space shuttle docks to it there, and the robot arm that you see. You'd think after 83 million miles or so, I would have gotten an upgraded seat on the space shuttle on the ride home. This is where they first told me I had to go, but actually this is in the lower deck or mid deck of the space shuttle, and it actually felt kind of comfortable. A lot of people say, well, how do you sleep up there? Excuse me. It's actually, it's in sleeping bags. You just tether it someplace, and the hardest thing for me was just I had lower back pain for like 45 days while I was up there for some reason. I don't know. It's just kind of a dull pain. Everybody reacts to weightlessness differently. Some people, they get violently sick for the first couple of days, and then they're okay. And then there's people like me we're just kind of have these gradually nagging problems for a while, and then I got used to it. But it is amazing how quickly the human body adapts to weightlessness. This was a landing in California. My wife also gives me a hard time because she was waiting patiently for me in Florida. And so we landed, and she says, that's just great. After 6.5 months, that's just great. You can't even come home to where you're supposed to. You can't even land where you're supposed to. Well, the weather wasn't good enough to land in Florida, so we landed at Edwards Air Force Base instead. I have put up the information up there. I'll leave it up there. But again, to go back to the psychological challenges of flying long-duration missions, is one thing to relate it to is, as probably everybody can relate to, let's say maybe when you went to school and you initially had a roommate that you thought was your best friend. Well, after you start living with them a while, you figure out some of the different idiosyncrasies, and those are some of the things that you just have to work through. Now, I'm not saying that we had big problems up there, but certainly we had some conflicts that we had to resolve, and I think that's an important thing just to let crews understand, and it's one of those things that I'm sure that NASA told us about it, but at the time you're in the training mode, you're focusing, and you go, okay, right, I got it, okay, I got it. I'll look for signs of depression at 3-month point. Yeah, right, okay, I got it. But it's things that you have to think about and understand. And it's important. And I think it's almost a good lesson in conflict resolution, because it was one of those things where you had to talk to the person. You couldn't just not communicate with them, because next meal you were going to be right in front of them again. So it was good. I think I learned a lot about myself and about working in close quarters with other people in that mission. That's all I had for kind of any prepared remarks. So I was going to go ahead and open it up for any questions that you have. Yes, go ahead.
How did you figure out your decompression times? Do you have like a table or a computer?
Yeah, her question was, how did we figure out our decompression times when we went on spacewalks? Essentially, it's a table. It's a standard protocol that they use. For the space shuttle, what the space shuttle does is the day before, they will actually bring the pressure down to 10.2 psi, and then that reduces the amount of time that they have to pre-breathe pure oxygen and to get out. What they also started doing was they came up, there was another astronaut named Mike Gernhardt who came up, helped develop a protocol to where you exercise and breathe oxygen through a mask, and that actually reduced the amount of pre-breathe time that we had to do. So now on space station, before they go on a spacewalk, they'll get on the exercise bicycle, exercise for I think it's 15 minutes or so, breathing pure oxygen. And so it's all by timeline. And so the ground, thankfully the ground is there to kind of keep us on schedule. So it is a very standard protocol, and the Russians have something similar, but they don't use the exercise protocol as of yet. Yes?
What precautions do you have to take to avoid getting a sunburn through the window?
His question was, what precautions do we have to take to avoid getting a sunburn through the window? They have UV filters, and actually there's on the side hatch of the space shuttle, there have been people, I won't name any crews, certainly I never forgot to do it, but anyways, there is a side window that, for whatever reason, they did not put a UV filter, and it's something you have to do after you get into on orbit. You have to install that UV filter. If you don't, you can pretty much get a sunburn, I think, in a matter of like 30 seconds. And you can see people with, obviously, they have this round kind of burn on the side of their face. So most of the windows are naturally protected, except for a few. Yes.
When do you think the flight to Mars will happen?
Yeah, his question is, when do I think the flight to Mars will happen? I'd have to go to the NASA website to look at the latest. The latest information that I think I've read calls for going back to the moon I believe in 2015, but I'm not certain of that. And I think that Mars certainly follows that, but I don't know what year right now. I'd have to look at the website myself. Yes, sir.
I'm kind of just interested in the relationship between astronauts and the ground. I mean, does that feel like your mom and dad telling you exactly what to do, exactly what you need to do every day? Did you have any flexibility in your schedule, daily routine?
Yeah, his question was, and it's a good one. What type of relationship do the astronauts have with the people on the ground? Basically, mission control, and did we feel like they were our parents? Did they feel like we had to do everything they told us to? And really, that relationship hopefully gets built up over, let's say, the year and a half before you fly, because you do simulations. You sit in a simulator where you bring the whole space control team in during the simulation, and you talk with them, not only the capsule communicators, but all the people that sit in mission control. So hopefully you spend some time and not only doing training, but also have some type of social events where you meet with them. And really comes down to what type of rapport do you have basically with your management. I mean, it's hard to, I always felt free. If we had a question about doing a procedure, like one time the ground said, we want you to do this maintenance procedure, and we had some concerns about it, so we went ahead and we wrote back, and then they wrote us back or talked to us and said, this is why we're doing it, and they'll come up with rationale. So our flight control team, I felt that we got along great, but it really is something that you try to establish, not only just after you get up there, but it's through the training. But most of the time, it's kind of like you're working together, and really the ground controls basically all the reboosts for space station, at least when the space shuttle is not there. So it is give or take, and we did have the leeway to, let's say, if I wanted to exercise in the morning and I wanted to trade with Yuri or Carl, I could do that. So that was more working with my crewmates to say, hey, can I do this? I can't think of a point where I was either cussing underneath my breath, saying gosh darn it, why can't they get that, or can't they understand that? But it really was not a us-they relationship. Yes.
Do you know what to look for on the space station? Did you find one which is familiar or completely unknown, or worried about that you have to figure out by yourself?
Yeah, I guess I think if I understand the question is, when I went on space station, did I find many things that were unfamiliar or that I had to work out by myself? Do you mean as far as the configuration-wise, or just?
Mechanics.
Oh, mechanics. Okay. Yeah. So most of when I got on board space station was not a surprise. Bits and pieces are mocked up, so we could train with mock-ups, and so most of it was not a surprise. I'm trying to think of, most of the training we do is in kind of fractional type of training. We'll train for a spacewalk, but it's in a pool, it's in a suit that's not exactly like the suit. But it pretty much all came together. But we did have about a week to talk with the crew that was already up there, and that was important because they would say, okay, this is how we kind of learned it on the ground, but it's a little bit easier to do it this way. So that was important. So that we did have a dedicated handover time. It was always rushed, but it is, the few minutes you have to talk to somebody to say, okay, how did you really do this, and that was very helpful. So I don't remember any big surprises up there.
Go on this mission that's 6 months, which is got to be so different than the normal shuttle missions. What sort of criteria do they use, or why do you think you got chosen over? There must have been lots of other people who were in line.
Yeah, his question was why was I chosen for this long duration mission versus, let's say, somebody else? Because the missions, as you can imagine, are somewhat different as space shuttle. And that brings up a point first I want to make is that space shuttle is more like a sprint. It's kind of like finals week. Everybody can relate to that. Finals week, where you very little sleep, probably living on a lot of caffeine more than you should. And then with space station, it's more like a marathon. You have to kind of spread it out because psychologically you can't be under that kind of stress for that period of time. As far as how they select, I know that they do some psychological screening, and it's different over in Russia versus the US. I remember distinctly the Russians have this test where you look at these pictures of different people and you pick out which one you like, and then they have colors that you pick out, and it's all very strange, but somehow I guess I passed. But to be quite honest, part of the biggest criteria early on in the flight was that you had to be, when you go to the amusement rides and they say you have to be, you have to be this tall to go on space station. Well, for space station you have to be shorter than this, because initially you have to fit in the Soyuz. Even though a space shuttle is taking you up, if the Soyuz is going to be your lifeboat, you have to fit in the Soyuz. So initially, until they modified the Soyuz, we had to fit, be within a fairly tight range of anthropometric measurements. So that was part of the selection criteria itself too. And you also get to work with, crews have been changed around in the past. I've heard a lot of different rumors of why they were changed around. Sometimes it was just because of the specific mission they were doing. They wanted a robotics person versus an EVA or spacewalk person. So sometimes that's changed around. But you go through survival training. Now they're sending crews on, I think they call it the National Outdoor Leadership School, or NOLS, where they go out and they, so a concentrated time under somewhat stress, and they see how crews react to that. I think they're looking at that as well. So that goes into it. They're doing a lot more when I was selected for space station, as far as put crews under stress and then see how they work as a team. Yes, go ahead.
Did you have any time up there to be not serious, like reading Harry Potter or messing with ham radio operators?
Yeah. Yeah, we had, I'm KD5PNU, ham radio license, and I didn't use a ham radio, sorry, his question was, did we have any time just to have fun up there and not to be serious? I hope I wasn't serious the whole time today, but yeah, we did, and that was important. Some people, like Yuri was closest to the ham radio. He seemed to use the ham radio a lot more than we did. We had DVDs up there that we could watch. Every weekend we had a crew movie where we would all go and watch a movie. I remember one time floating back. Where I slept was in the U.S. segment, in the U.S. lab. Yuri and Carl were back in the Russian segment. That's just happened to be where their quarters were. And I remember floating back. It was crew movie night, and I remember floating back there, and I see Yuri and Carl both with each with one of the speakers. We had the portable speakers with the DVD player, watching the movie, each with one of the speakers to their ears. And I guess they wanted to squeak out every little bit of battery that they had left in the speakers, before they changed it. Part of the problem was it could be very loud in some of the pumps that were back there. So we watched DVDs, we read books. I had books on tape. And so everybody had brought up, you could bring up a little package of hobbies. Yuri was fishing, so he brought up what he hoped to do was actually, I think, tie some fishing flies. I don't think he ever got to do it, but you try to do something, think of things that you like to do when you're up there. Other people just the ground had a long list of, it was kind of a to-do list. They called it the job jar, and so you would go in there and take up your time doing that. But I would say overall was pretty, we had the time to do that, but mostly during, let's say, half a Saturday and some of Sunday, we would do that. Yes? Go ahead.
So what was your mission? Why
Yeah.
did you go up there?
Yeah, our mission was continue building space station. One of the flights that came up brought up that truss segment that you saw. Let's see if I can go back to it. Yeah, it was that truss segment that came up. The experiments that I was in charge of, I had a plant growth experiment that one of the challenges of going to Mars is trying to grow, let's say, in an enclosed environment. Space station right now is very much a throwaway environment, to where we use things once or twice and then we don't reuse them. Some of the water, the condensate, is collected from the humidity in the air, is reused. But on a mission to Mars, I think they're going to have to rely much more on a total enclosed environment. So one of my experiments I had was a plant growth experiment. Apparently with growing plants, plants not only scrub the CO2 out of the air, they also put other gases into the air that could be harmful in an enclosed environment. That was one of the experiments I did. I enjoyed that particular one because it was very much a hands-on experiment. Some of the other experiments we had were protein crystal growth experiments. The robotics, much of the robotic arm work that we did was in preparation for future build missions, was working out. The robotic arm was relatively new, so we had to work it out before they brought up other big segments like in the middle here, this big truss segment that goes across the US lab was installed using this arm, and it had lifted the airlock before, but nobody had used the procedures that were going to use that segment itself. So much of our time, unfortunately, is spent on just maintenance of the space station. The amount of science, I've heard that they want to increase and focus it more on long duration and going back to the moon and on to Mars. But with only a 3-person crew, that's tough because, you seem to spend a lot of your time doing a lot of the upkeep. But hopefully, as more modules get up there, they can increase the size of the crew. Other crew members had their own experiments. My least favorite experiment were ones that kind of I was a test subject. There was one called it was actually looking at I had to be careful here. I don't want to tick off the principal investigator for this one, but it was a particular experiment where I had to put electrodes on my leg and take shocks to my leg, and then they were measuring the reaction and my reflexes. So that wasn't my favorite. But the ground always has a sense of humor. The box for that gave you the shocks, the acronym of the box was HRTU, or hurt you. So I mean, they have to have a sense of humor. But, thanks. Yes. Yeah, her question was, how did you feel coming back to Earth and feeling gravity again? On a space shuttle mission of 7 to 12 days, usually you feel, I kind of felt normal after 3 hours or so, but even when you first land with that, your arms feel like they weigh 100 pounds. They just feel very heavy. You just feel exhausted even just to lift your arms. Whereas coming back from space station, one of the biggest effects was neurovestibular-wise, whereas if you think of it, your inner ear is kind of disconnected. So if you think of it as a peripheral, on your computer that is disconnected, and then you connect it again, you land on Earth, you connect it again, and then all of a sudden your brain is going, unknown equipment, detected, no driver found. And that was kind of what it felt like when I landed back on Earth after space station, because all of a sudden, my inner ear now is giving me all these signals of sensing gravity again, and my brain hadn't felt those for such a long time. It said, what's going on? And I immediately pretty much got sick to my stomach, and it was all neurovestibular. And I asked the flight surgeons, I said, well, why am I feeling that? And they said, well, it's kind of a protection mechanism that your body has. If it doesn't understand what's going on, it assumes you ate a bad berry. And so that's what it was. It was saying, I don't understand, So, so that lasted several hours, and then just walking took about 3 days to kind of get used to where I could walk again. And I would say cardiovascular-wise, I like to run. Cardiovascular-wise, I would say just anecdotally, just in how I felt like even after a year, I wasn't quite where I was before, because it's a huge impact on the heart and the body, being up there that length of time. So, what? Oh, okay.
Are there experiments on the space station that are multi-year experiments? And what kind of data is going back?
Yeah. Some of the experiments last just a few months, like some of the protein growth experiments. You initialize them, and then they're done after a couple months, and then they'll go back on space shuttle. Other experiments, they may use the same equipment, like the glove box, but most of the experiments typically last, the longest I would say would be maybe 6 months, to where if you're collecting data, let's say collecting bone density and calcium data on the astronauts, that would last throughout a mission. So it varies from time to time. Go ahead.
Do you think the centrifuge combination module might react?
His question was about the centrifuge module that I believe was removed at one time. I don't know. I don't know and have an update on that. But certainly, if somebody can prove that using it has a benefit as far as going back, direct benefit as far as a human lasting a long mission, especially onto Mars, that they should bring it back. Yes, go ahead. Yeah, his question was, did I get taller? You actually do. I grew about 1.5 inches in space, but a lot of times people say gravity sucks. So I came back down and I shrank a bit. And that's actually something they have to account for with the space suits. When you go out, they actually size them a little bit higher because they know that your body's going to stretch a little bit. But come back down to Earth and I'm the same height, so up there. But I think that's, we'll go ahead and end the video part at this point. But thanks very much for your attention today. And I'll be able to stick around for a little bit and answer some other questions. Thank you.